In order to get you started on today's classwork, I wanted to make this video to give you an example of how to approach this exercise. It says, consider the polynomial function f of x equal to 3x squared plus 8x minus 4. And we're going to divide that function f by this binomial factor. Well, maybe it's a factor and maybe it isn't. If it divides evenly, it's a factor. If it doesn't divide evenly, there'll be a remainder, and we'll see what to do about that. So let me just set up the division problem here. 3x squared plus 8x minus 4 divided by x minus 2. So first of all, I'm going to notice that if I multiply this leading term, this x right here, if I multiply it by 3x, it will give me 3x squared. And then if I multiply the other term, 3x times a negative 2, that gives me negative 6x. Subtracting leaves me with 14x, and then I bring down my minus 4. Now I have to multiply this leading term by 14 in order to cancel this out. So let's see what happens. 14 times x, 14x. 14 times a negative 2, that's negative 28. Now when I subtract, I actually end up with this remainder, 24. Okay, so what do we do? Let me just write out the problem. 3x squared plus 8x minus 4 divided by x minus 2, that is like 3x plus 14, okay, plus 24 divided by x minus 2. So really, when I divide x minus 2 into this polynomial, I get 3x plus 14, but there's a remainder of 24, which I need to also divide by this divisor. And so this is really the solution to this division problem. Not pretty, but mathematically correct. And our work today is really taking a look and understanding this remainder and its relationship to this potential factor. You know from our work previously that x equal to 2 would be the root or the 0 that comes out of this. And that's why they're asking you to determine f of 2 here. Let me show you what f of 2 is. I'll just take my function f and plug 2 in for x. I get this expression, and of course I can simplify this. This becomes 3 times 4 plus 16 minus 4, which is 12 plus 16 minus 4. That's 12 plus 16. Let me write it out. Minus 4. It becomes 28 minus 4. And what does that equal? 24. So notice this lesson is called the remainder theorem. And basically what the remainder theorem says is that if you take a polynomial and you divide by a binomial, then the remainder, you can determine what the remainder is going to be from that division simply by plugging in whatever value makes this binomial equal to 0. In our case, it's 2, so when I plug 2 into the function, the original function that is, I get 24, which is also the remainder I get when I divide. So you can go ahead and demonstrate this by solving questions 2 and 3.